Spirit of Aviation Week.
Hi everyone, and welcome to EAA Together. My name is Mark Forss from EAA, live from Oshkosh, and this is...
I'm Joe Norris. I'm the home building program specialist here at EAA, and I'm going to help Mark out with some of our demonstrations today.
Great. So I manage the EAA Sport Air Workshop program where we go around the country teaching folks how to build airplanes, and today we're going to do a little workshop on the aspects of building a sheet metal aircraft. So let's get started. Let's talk a bit about airplanes, Joe.
Yeah, sheet metal is a very, very popular mode for building aircraft nowadays. There are many highly developed kits that are sheet metal aircraft. The entire Vans RV series, of course, the most popular one out there, and there's the Zenith aircraft, Sonics aircraft, and a number of others. So there's lots of building going on in the sheet metal realm, and a lot of stuff at your local chapters, and it's really one of the most popular methods, so we're going to talk about that today.
Yeah, so sheet metal has really changed over the years. Back in the day, a legacy aircraft, a sheet metal aircraft, you'd buy or get a set of plans,
right,
and then literally a roll of aluminum,
and
several rolls of aluminum, right, and then have at it.
Yeah, you did all the layout, all the measuring, all the drilling, everything was from raw materials. So it was up to the builder to do the entire process from the raw materials forward.
Exactly, and it took a lot of time. I mean, literally decades.
Yep, and over the time, they developed the kits, more and more pre-cut and pre-drilled materials, and now, of course, as we'll talk about in a minute, we go up even into the quick-build kits where a lot of the aircraft is already taken care of by the time you get into your garage.
Yeah, computer technology has really changed a lot. Over the years, it's developed from $100,000 workstations to literally PCs that cost hundreds of dollars,
right.
And the software has changed too, from literally $1 million CAD packages, computer-aided design programs, down to programs that are virtually free. Now, the manufacturers are using more sophisticated things than that, but they have been able to take the design and get it to the point where they design the airplane, put it in the computer-aided design system, and then output it to a machine that then cuts the parts. So literally it comes together almost like Lego, and that's pretty amazing.
It's very much like building your model airplanes that you used to build as a kid, where you came with a left half and a right half and a couple of wings, and you just glued it together. It's not quite that easy.
Not quite that easy, no.
Working towards that. It's much more streamlined and much more less and less of the actual raw material work and much more of the final fitting and final layout and then final assembly.
Yeah, so it seems like most of the kits today, although you can still build a legacy airplane like that. I mean, if you still want to buy the plans and buy the raw materials, you can still do that. And there are some people that just love to build and go about it that way.
Most all of the kit vendors still do have their legacy plans available. Sonics and Vans, you can still buy the real basic plans and the real basic kits and really do all of it yourself. That is really the least expensive way to do it. You're trading your money for your time.
Exactly.
So the more money you put out to get a more sophisticated kit, the less time it'll take you to complete that aircraft.
Yeah, a lot of times I'll tell folks that I'm instructing about building things is my time's valuable, their time's expensive.
That's right.
That's what it comes down to.
Right. That's exactly right. Some people, they look forward to some of the processes to learn the things, but they don't want to get into the time-consuming repetitiveness of a lot of making each individual part. So the kit is kind of a nice balance between that.
Yeah, and at the end of the day, what we truly want to do is not be building for the rest of our lives. We want to fly these creations.
And again, as you mentioned, there are some people that really are into the building process.
Oh, yeah.
Build an aircraft, complete it, fly it for a while, and sell it and build another one.
Yeah.
And so there are those builders out there that really love to build.
Yeah.
But I think the greater majority of us are all looking for an airplane that has the performance we want, has the equipment we want, and we can put it together ourselves, so you have a vested interest in it, so you get a little bit of building and a lot of flying.
And there's no greater thrill than jumping in an airplane and flying to a pancake breakfast than the airplane you've flown and built yourself.
Exactly. Yeah, that's the real crowd pleaser.
It really is.
You bring it to the flyer, and yes, I built that airplane.
Exactly.
It's amazing.
So what we want to do today is kind of give you a glimpse into the background of building a kit aircraft. There's several different popular styles of kits, and in today's today's program, we're going to talk about how we build some of the more popular kits that are on the market today, and actually show you some of the tools that are involved in doing this, and go through a building process. So I want to show you right now two of the different types of kits that have become very popular. One is what we call a standard kit. So a standard kit is a kit of parts that an aircraft manufacturer puts together. They've done a lot of the hard things for you.
Right. For example, most of even the standard kits nowadays don't require any welding.
Yes.
A lot of people, they're not set up to weld. They're not really interested in welding, and they do it if they really had to, but that saves them a lot of time and saves them some equipment cost and some time, spin-up time for learning. So the welding is done, maybe some real intricate forming might be done for them.
Yes, like the plexiglass canopies. I mean,
Exactly.
it's very challenging. I mean, these are the challenging things that you have to do to build an airplane, okay? Plexiglass canopies, fiberglass construction, to get those smooth fiberglass parts you see on vans, RVs, and Sonics and Zenith. Right. That takes a lot of work because you have to make the molds and then make the parts, and
a lot of sanding, a lot of layup, it's very time consuming.
So the kit manufacturers, as you can see from that picture that we have up on the screen right now, they've taken away a lot of that, where they have the fiberglass components already done. Yeah. The cowling already done.
Yeah, the welding, the canopy is already formed.
Yeah.
A lot of that type of stuff where it's very difficult to do that in a home shop.
And then depending on the flavor, they'll have some of the harder things done for you, like the spars already pre-built. The critical things that people get kind of nervous about building.
Right, exactly. Yeah, pre-built spars is a very popular option even in the standard kits.
Yep, exactly.
I mean, that's another very repetitive riveting process where you need some pretty heavy-duty equipment, and it takes a lot of layup time and some pretty good precision to get it straight and square the way you want it. And they just leave that to the manufacturer who can do it in their equipment in no time at all.
Exactly. So you can see on the screen there's a lot of parts there, but there's still a lot of work involved in building these things. Right. So when you're actually building a standard kit, you're part-time, and when you put time into it, and one of the things I like to really push people is that a little bit of time every day ends up with an amazing result.
Exactly. That goes back to even the early builders, the early kit, even the designers and the plans builder, they always said if you could work a little bit every day, even if it's just a little bit.
Yeah.
Every day you get something done, that's one thing less you have to do going forward.
I mean, exactly. I mean, it's like one sub-assembly done today, you can set that aside, start working on something else, and then suddenly you have a whole collection of sub-assemblies that come together very quickly for that final thing.
And that's a good point too, Mark. If you think about the aspect of, yes, it's going to take you some time to do this, but you don't want to sit there at the beginning of the project where you've just unboxed the kit and say, I've got to build this entire airplane. It seems overwhelming.
It is overwhelming,
But if you start with one little part, a rudder, a stabilizer, and I want to build this rudder, and by golly, you finish that rudder.
You're focusing on it.
And it's, hey, that's an accomplishment. It's something you've done, and you've completed it, and you can reward yourself for that. And then you build the next part.
Yeah.
And the next part. It's all these little sub-assemblies, and they're all little victories in and of themselves.
Exactly. And that is part of the thrill of doing it, too. It makes you, the good feeling you get.
And it's something you got sitting in your shop when your buddies come over and say, oh, yeah, here's the rudder, here's the stabilizer, and so it's all talking points with your chapter mates or your building buddies and that.
Yep.
So it's all part of that process, and it's part of the community aspect of it as well.
And the other thing I'd like to say too, and I think you're kind of pointing this out, is at the end of the day, this is a fun thing. It's not a job. We're doing this for fun and enjoyment, and doing because of that.
You have to enjoy the building process because it is going to take some time, but it is very enjoyable. And the people that really enjoy it start with plans. The people that kind of enjoy it do a standard kit, and the people that really want to get it done go to the quick build kit.
Quick build kit. And so let's talk about the quick build kit as we move to the next picture in the slideshow. So a quick build kit is where the manufacturer has completed some of the major assemblies. So literally out of the box, the fuselage is usually done, the wings are done. What's nice about that is they've done some of the time-consuming fixturing in terms of getting the wings, everything rigged properly, the fuselage aligned properly. There's still, even though there's a difference in terms of the amount of parts that are already put together, compared to the parts that you have to do, there's still a fair amount of work, but it dramatically cuts down the time.
Right, it cuts down a lot of the repetitiveness, and it also gets you to the point where most of these kits that are quick build kits, or in fact all of them that I know of, have been evaluated by the FAA, and the manufacturers of the kits have taken them right up to where they still meet the requirements for the amateur build certificate, but they've done as much of that major construction that they can to get you up to that point. So it really is, again, you're trading your money for your time.
And that's a good point to talk about, is what actually qualifies as an experimental amateur build. And that is ultimately a major portion of the aircraft is fabricated by you as the home builder.
Yeah. They call it the major portion rule. Most of you in the chapters and out in the field have heard of the 51% rule. That's what they're talking about. And the FAA is talking about the tasks that you perform to build the aircraft, and you need to do a majority of those individual tasks. So, and the FAA has a checklist that they go by to check those off. So they go to the manufacturers, they look at the quick build kit, they check off all the tasks the manufacturer does, and they make sure that there's still enough tasks left for the amateur builder to do to get that aircraft certificated.
Yep, absolutely. And in terms of time goes, we have our standard plans or scratch build kit. We have our standard kit then, and then we have our quick build kit. Time-wise, it could be, decades to years to literally months, depending on how you want to do it. I mean, if you look at, for example, like the one-week wonders that we've done, that's down to weeks. But of course, we have hundreds of people working on that. That's a little bit different, but it just gives you an idea of what you can do with some of the kits.
Right, and if you look at it that way, a person who might be retired has the time to do it and spends a lot of time in their shop every week, they can get an airplane done in less than a year without any problem.
Right.
Most builders don't push it quite that hard, but it can be done. But it's really common on a quick build kit to see an airplane get done in a couple of years.
Yeah, and what I like to tell everyone too is that at the end of the day, anyone out there can build an airplane. It's not that difficult. This is not rocket science, although it is kind of rocket science in a way it is, but it really isn't, because the tasks that are involved, the skills that are involved are not things that...
Anybody can learn these skills.
Yeah.
I mean, some people, they might be a mechanic or they might be a carpenters, they might have some of the skills already.
Yeah.
But even if you're not from that background, and you haven't really done a lot of hands-on mechanical type work, these are all simple tasks.
Yeah.
And with a little bit of time and a little bit of effort on the builder's part, all of these can be learned by virtually anybody.
I mean, it truly can be. I mean, it isn't like, if I were to pick up a guitar and start trying to play that, I mean, I'd be a basket
I've been trying to do that for years, but I still haven't quite figured it out. So.
But you put anyone in front of a kit of parts, and by following a simple set of instructions that have already been kind of proofed out by the manufacturer, it's a piece of cake.
And of course, obviously, you mentioned our Sport Air Workshop program, which is another way that they can just get a little bit of hands-on training while being observed by a builder that has that knowledge. And that's leagues ahead of where they were, and it just costs them a weekend of time.
Exactly. So we talked about the types of kits, quick build, standard as kind of the two major ones right now, and the outliers being a scratch built or buying one that's already completed. But ultimately, then we kind of evolve into how the kit is manufactured. And there's two ways that go about that. We have what we call our standard aircraft construction. And what that is we're using solid rivets, a traditional aircraft method as far as building these things, where we're driving rivets essentially with a rivet gun, bucking bar. This goes back to the 20s and 30s. I mean, it goes back to
World War II and began even before that. They were already building
Rose of the Riveter and everything like that. I mean, it's the traditional aircraft method. And then a newer method in terms of kit construction, based off of commercial uses of materials, is pull riveting. So pull riveting dramatically reduces the skills and technique of driving the rivets, and makes it, in many cases, a one-person job, right?
Yeah, a lot of cases when you're doing rivet rivets, you need somebody on the other side of the structure for running the bucking bar. Making sure that things are aligned properly. With the pull rivets, it literally gets down to a one-person technique.
Yeah, so as we look at the screen right now, this is a traditional method using a rivet gun, bucking bar, rivet set to build a typical RV-style airplane. And then the newer, or what's becoming more popular, because it's easier and faster to do, is using pull rivets, commercial or aviation quality pull rivets.
Right.
And we're going to be demonstrating that technique, and this is where many of the designs from Zenith and Sonics and the newer RV series aircraft are being used, because it's easier, it's much faster, and you still have that same high quality of aircraft construction.
Exactly, yeah, the designers have investigated all the different structures and rivet types and everything, and they've come up with rivets that are equally as strong or even stronger than the traditional aircraft rivets, and so much easier to install and quicker. And a lot of times with less outlay for equipment and material.
Exactly.
And tools and everything.
Yeah, I mean, it comes down to actually you can use hand tools sometimes too, without having any kind of special air compressors or anything like that. So we're going to show a demonstration of that in just a little bit. But before we do, as you're building your kit, one of the things you want to get set up is your workshop. So here's a picture of my workshop a number of years ago when I was starting a scratch-built aircraft. But you want to have a nice, comfortable space. Again, this is a hobby. We're doing this for fun. It's not a job. So you want to be comfortable. You want to have it well lit.
Very important.
You want to have it near to where you live, in your garage, in your basement.
Shop that's near your home or something like that. The closer that you have it to where you live, the more you'll get a chance to work on the aircraft.
Exactly.
And that's what we talked about every day.
Every day, a little bit of time.
If the aircraft is at the airport 20 miles away, a lot of days you're not going to have time to drive that 20 miles, even just put in a half an hour time and drive home.
Exactly.
It's down in your basement or out in your garage. It's pretty easy to walk out there and spend a half an hour a day or an hour, and you're right there at home.
Exactly. So it's quicker that way. You don't have that excuse.
Exactly.
You know, you get home, sit on the couch. Maybe I will, maybe I won't. Usually you won't, but hopefully you will, and that's one of the keys.
Quite frankly, with a lot of the smaller parts, when you first start building some of these small subsystems, you can literally do them on your kitchen table or on a couch in the living room while you're watching TV. I mean, I've seriously talked to builders that have done this.
Yeah.
So you spend some time with the family and still get some work done on your kit all at the same time.
And
that convenience factor is really important.
And that happens more often than not, because a friend of mine did that. He lived in an apartment, and he started building his empennage for his RV on his kitchen table. Now, I'm not sure how he did that, riveting in an apartment on his kitchen table, but he did it. And he got it done. He got his airplane done, so he can do that. So whatever works for you in terms of a workshop, that's the way to go. It can be something
more convenient, the better, and the more light you've got. Lighting is really one of the key things. I mean, you can have a really very elaborate toolkit, or you can have a very simple toolkit, but if you can't see what you're doing, it's not going to matter.
Exactly.
So lighting is really one of the.
It really is, and I really geared in on that when I built my shop. In that picture, I have 2, 4, 6, 8, 10, 12, 14, 16 18-foot or 8-foot fluorescent tubes lighting things up.
And that's exactly what you need.
Yeah.
You're able to see, especially when you get down to fitting some smaller parts or checking a rivet fit or something, you need that light to be able to see.
Yeah, exactly. So that makes a huge difference. And comfortable too. You want to make sure that it's air conditioned in the summer, heated in the winter, just comfort as well.
Yep, exactly.
So when we were building the EAA 750 Stoll airplane just a few years ago, there was kind of a quick shot. I mean, it wasn't perfect because we were in the corner of the hangar, but it was an organized space where we could go to it, work on it, and then leave and then come back. And that's another thing too. I mean, if you're sharing a space with a car where you have to pull the car out, get your workspace set up, work on it, and then put it away, all those things add time.
Yep.
And you can't.
And it also is one of those less convenient things, so you're not as apt to work on it because, I got to set it up, but my son's going to be home in half an hour with the car, and he's going to want to put it in there, so it really doesn't pay to get set up.
Yep.
Whereas if you've got a place where you can set up and leave it set up so that you can just go from operation to operation without having to change a bunch of things around, is really going to streamline your build process.
It's a huge difference. A huge difference.
Yes, it is.
So once you have your workshop set up, you've ordered your kit, now you have to be prepared for delivery. And that's something that not too many people think about. They're waiting for the package, but this is not a package from Amazon.
No, exactly.
This is a huge, either a crate, a wooden crate, or in the case of the Sonics picture that we have here, a pallet. And this is a unique way to do it because they can de-pallet the boxes rather than having to take the whole thing off.
And more of the kit manufacturers are going to this where they'll compartmentalize all the subcomponents so that they've got enough
number of different boxes strapped to a pallet, so a couple of people can unstrap those boxes and box by box and load them off without having to have something that'll lift the entire pallet at once.
Yeah.
Some kits still come in a big crate, and you need to verify that with your kit manufacturer so that you know that, oh, I need a forklift when that thing gets here, or I need to take it to my local loading dock and let them unload it, and then we'll figure it out from there, or whatever, because you don't want to be the person that's standing there figuring out how to load this thing by hand and have the truck show up with a 18-foot long crate that's 6 feet high and 4 feet wide.
And thousands of pounds, right? So you got to plan ahead in that regard. And that's what's nice about, again, some of the kit manufacturers where they are selling essentially packages. You start out with the empennage. One of the least critical, I mean, it's important, but it's least critical in terms of building your skills, and then you go from there to maybe the fuselage, wings, and the completion kits, so you can get them in small packages that you can build up your confidence and comfort level as you move on to your things.
Another couple of problems that solves is the fact that the cost is spread out. You don't have to buy the whole thing at once. You often will get a break if you do buy the whole thing at once, but many builders buy them individually in the subcomponents. You buy an empennage kit, you buy a wing kit, you buy a fuselage kit. You can spread that cost out, and you store the things individually too. So you get the tail done, you hang it on the wall, it doesn't take up any room. You get the wings done, you make a little rack, push them against the wall, they hardly take up any room, and you've got room to work on your fuselage. So you can satisfy your storage issues, and you can satisfy your cost issues all at the same time.
And that's a huge thing as far as storage too, because if you start out without a big workshop, and some people have actually done things as we talked about on their kitchen table. Some people have built their wings in their hallway. I mean, whatever it takes to do, they do it, but it's nicer to do it in segments, and then ultimately bring it out to the hangar or the airport and do the
final assembly is going to be out, likely to be out at the airport, correct.
So the next part is following instructions, but before we do that, I want to kind of show you, just to give you an example how easy it is. So I'm going to go over here for just a moment and bring out this. This thing. So I'll tilt it back a little bit so we see. So this is an example of an empennage kit. This is a rudder kit that actually I participated in recently for Zenith. They had their virtual build of their the rudder program. Example of a kit that's already put together, a kit of parts, the rudder kit, and how easy it is to put together. I started this at 10 a.m. and I was done by 1, so roughly 3 hours-ish of work.
You went from a box full of parts to an actual finished rudder.
Yeah, and then you're done with this. And then literally it was putting together like Lego. I mean, with the kit manufacturers, all of them, they've gotten the design down and the manufacturing processes down, where you don't have to do anything in terms of laying out the holes. You don't have to worry about holes being mismatched or anything like that. It's a huge difference.
There are a few parts that you have to fabricate, and the reason you do that is because the FAA requires that the amateur builder does some fabrication, so they leave a few things in there that count towards fabrication for the builder to do, but primarily it's assembly, and a lot of times it literally is almost like a tab A, slot B, follow the instructions, put these parts where it shows you, and put them together.
And still qualifies for the experimental amateur build.
Correct.
And at the end of the day, you get flying faster.
True.
And that's a huge difference. So, but a great example of how easy it is. And a lot of people are so concerned about this. You know, this is going to be something that's just going to overwhelm me.
And you mentioned that this was a virtual workshop that Zenith did, and a lot of manufacturers are doing that to get their builders some really basic hands-on experience. You get the kit, and then you go online with them, and they walk you through the process, and it's really a nice setup.
It really is. And then, so ultimately, that's what you can do. But one point, and we were talking about this earlier, is one of the big deals is that you have to follow the instructions. You can't deviate. So folks like Zenith, Sonics, Rands, step-by-step instructions. So it's not so much a set of plans where you have to interpret the plans and figure out what goes where. It's literally a list, step-by-step, of how you assemble it. You get part A, bring it over to part B, align the holes, put in the fasteners, done, then you go to the next part.
Yeah, they'll give a page and they'll have a drawing on there, typically like an exploded drawing.
Yeah, and it will look something like this, actually.
There you go, on the screen there you see it's an exploded drawing showing kind of a relative arrangement of all the parts, and then there'll be a list of all the parts by part number, and of course the kit manufacturers number all their parts, so you can easily go to your kit, find the parts you need, line them up, put them together in accordance with the step-by-step instructions, and there it is.
Yeah,
It's really
really simple that way, absolutely. So we have our kit and we have an understanding of how to go about it. Now let's talk quick about the tools that are involved, okay? So the tools that we use are not necessarily stuff you can buy at the hardware store.
Some is, some aren't. Yeah, there's some specialty tools that are nice to have if you really want to streamline your build process.
Yeah. So we've got a suite of tools outlined out here on the table, and we just want to talk a bit about some of them that are involved, some of the unique tools that are used in aircraft construction, and some of the tools you might be able to find locally to put together parts.
Yep.
So when we're looking at an aircraft that's put together with solid rivets, we need a rivet gun. So we have an example of a rivet gun here. It's air-powered, a pneumatic style gun. And if we can go to the close-up on that, to take a look at that quickly. We have an air-powered tool, which needs an air compressor.
Air source.
And we have a rivet set, which goes into the rivet gun, and that actually goes on the rivet itself. And then along with that, we use a bucking bar. And those are the elements that drive the rivet, okay, for solid rivets. Now, this is a kind of tool that you can't buy at a hardware store. You have to get it from an aircraft supplier, readily available. So that's kind of a unique tool in that regard. When we go to the construction method where we're using pull rivets, we can use a pull rivet gun that looks something like this, okay, and this is a hardware store style pull rivet gun, hand squeeze gun.
They'll call it a pop rivet gun when you're at the hardware store.
Exactly, yeah.
We don't like to use that term because pop rivets truly aren't construction quality, aircraft construction quality.
No, we're not building a screen door.
But it's the same tool.
Same tool. Basically, it grips the rivet, and we'll see how this works in just a little bit. The challenge with this is that it's a manual tool. And you're squeezing this by hand, and thousands of rivets later, it's going to take some time to do. So that's
plus,
a challenge.
You're going to get one really strong forearm and one not so strong one if you're using the same hand all the time.
Well, that's exactly it. So we go from this to an air-driven tool. So we have that actually behind you there, Joe.
Yep, I've got it right here, Mark.
So this is the same kind of design where we're pulling rivets, except it's pneumatically driven. We use an air compressor to do all the heavy lifting for us. We're basically just pulling the trigger to make it work.
And then you can do literally thousands of rivets a day with one of those.
Yep.
It never
And
gets
nothing-
tiring.
nothing to it.
And everyone is done exactly the same. It's a very, very handy tool to have, and they're not that expensive.
No, they aren't. They actually...
You can probably not at your hardware store, but a lot of your specialty tool stores will have these, and of course online you can also get them.
Exactly. So that's our tool that we use for pull rivets, okay. Another essential tool that we use for putting aircraft together is a drill. And we like to use an air drill if possible. So this is an example of an air drill. Again, driven by air pressure, you need an air compressor, okay. The other style of drill that we'll use for building aircraft is a battery-operated drill, okay? So what's the difference between the two? Basically, it's the RPM of the drill. And what it comes down to is an air-powered drill has a much higher RPM. And that will actually give you a better drill hole, cleaner hole, as compared to a battery-powered drill that is much less RPM. You know, you're talking about 3,000 RPM-ish compared to maybe 500 or 600 RPM. So it gets the job done. It takes a little more time to do. The air drill is preferred, but if you don't have an air compressor,
It's perfectly simple to do with your battery-powered drill, or even a plug-in electric-powered drill.
yeah, exactly. What's nice about the battery, too, is there's no connection. It's much more portable that
Which is actually
way.
a benefit over the air drill, because you do have the air hose to have to deal with if you're using the air drill. But again, the benefits of the air drill certainly outweigh that.
Yeah, it goes back and forth that way, exactly. So a drill is one thing. We do have some other specialty fasteners, too, that we use to put things together. And we'll get into those once we start actually building the part. A suite of tools, you're probably investing, with, including some of the specialty tools, maybe anywhere from $800 to $1,500, I'm thinking, right?
Right, depending on just how elaborate you want to get, and you know, some tools you may already have, some people might be starting out from scratch, I mean, literally buying their first tools, so they'll be a little bit more invested there.
Yeah.
Some people are just going to build on what they have at home already, so you know, they might have a head start a little bit.
Yeah, a little bit, yeah. And one of the nice things is if we go to like some of the manufacturers and suppliers rather, like Aircraft Spruce, they will have, and they partner with the manufacturers with a specific tool package. So if you're just starting out, you can buy the Sonics toolkit. You can buy the Zenith suite of tools.
Right.
You can buy tools that are designed that work with the intricacies of an RV aircraft.
Correct, yep.
So going to a supplier like Aircraft Spruce is a great way to get your starter kit.
Right.
And then just like anybody, you can never have enough tools.
Right, once you buy one tool, you're going to buy some more, we'll guarantee you.
Yeah, absolutely. But that's a great start.
Right.
But by the time you're done, I think I invested when I built started building my airplane, and this is maybe 20 years ago or so approximately. It was about $1,200 for the basic things that I needed. I've added on to that and got some other kind of unique tools, and I'm sure you have too. And of course that adds to it. But that adds to the fun. And the other thing that's nice about that is these tools are an investment not only in building your airplane, but also in maintaining your airplane. Correct. So ultimately, if there's things that have to be maintained over the years, you have those tools to fall back on to take care of.
Yeah, and the other thing to think about too, Mark, with tools is that nowadays a lot of your EAA chapters have a tool crib, where some of the more expensive tools that maybe you're going to build one airplane, you figure you're not going to want to spend a lot of money on some of these specialty tools. So you can go to the chapter and they'll share tools among the other builders. So the chapter will have a rivet squeezer, a set of scales, you know, a number of different things that maybe it's not something you really want to invest in yourself for a one-time use maybe.
Yeah.
But the chapter can share those tools and everybody gets benefit out of it that way. So the chapter is a great resource for that type of thing.
So it's like a lending library in many respects, yeah.
Exactly.
That's great.
Yep.
And that's one of the benefits of being a chapter member and, you know, connecting with a chapter nearby.
Yeah, the help you can get from a chapter, along with the fellowship and camaraderie, is invaluable. It's really amazing.
Cool. So before we run out of time, let's build something.
All right, sounds good.
So this is an example of one of the projects that we build in the Sport Air workshops. We don't have time to do this. This is a 2-day project, okay? But typically, when we're doing the EAA Sport Air Workshop sheet metal project, we'll build a project that is similar to what you'd be doing in your airplane in terms of the number of the elements. We're putting in a rib. We're doing solid rivets mainly. We're putting in a hinge flap section, inspection hole, doubler, front spar, rear spar, that sort of thing.
Sure, you build a little mini wing there.
Yep, exactly. And at the end of the day, quite frankly, if you can do this, you can do anything.
Yep, if you can build that little part, you can build a whole airplane.
Yeah, and
you just keep repeating the process.
Exactly, you know, over and over and over again. You know, and that's a key point, is just practicing.
Right.
The first couple of rivets are probably going to be on the edge, and that happens all the time.
Yep.
But you do more, and you do more, and you become more practiced at it, and
Pretty soon you're just going through them and there's nothing to it.
It's second nature.
So
Yeah, it really is. So we're going to do something similar to this in terms of using some of the parts, and we're going to be using that technique of using the driven, the pulled rivets this time. So we're going to set that aside, and then we're going to look at some of the parts that are typical that you'd find in a kit. So here's a raw part. Okay, this is what we call our bottom skin. And when we get this in the kit, it's pretty much set for us. We don't have to do any layout because the holes are already been pre-punched for us. Depending on the manufacturer, they'll either laser cut these, or they'll use a CNC machine and then cut out and then drill the holes that are needed.
Right.
So this is like, in terms of the the challenge, this is like 90% of it.
Yeah, as of, that you get this part already in this condition, as opposed to getting a square blank sheet of aluminum and having to figure out where that hole goes and how to cut it.
Yep.
And what the spacing is on these rivet holes and lay those out individually, mark them and drill them each.
Yep.
So I mean, look at the time that's saved just by getting that part already.
It's a huge difference. It's a huge difference. And that's really the kind of the huge shift in being able to successfully complete an airplane very, very quickly.
Great.
So let's build this, okay? So typically what we'll do, we're going to be following a set of instructions. And the instructions will tell you to, first of all, identify the parts, okay? The other thing you want to do is you want to make sure that the parts are ready to assemble. So sometimes the parts will actually have protective coatings on them, plastic coatings that minimize scratching. Now, a lot of builders will keep the plastic on as long as possible, but you got to remember to take that off ultimately.
Yeah, and the other thing to remember, the longer that stuff stays on there, the happier it is to stay on there forever.
Yeah.
So there's a time when you really should think about trying to get it off there before it becomes unified so much with the part that it's this overbearing process.
It's a mess.
Yeah, it can really turn into a major project to try to get that off if you leave it on too long.
Yeah, exactly. And so make sure it's off. Absolutely.
Yeah, especially, obviously, the most critical is where you're going to join two parts. You don't want that plastic coating in between there. You're not going to get a proper joint.
Right.
But even on the exposed parts where there's no actual construction going on, sooner or later you need to get that plastic
Yeah,
off there.
absolutely. So we have the parts, we've identified them, we've got them set. Another thing that we need to do with the parts is deburr or clean off the parts. So the parts when they're manufactured has some rough edges to them, okay?
Right.
There's a couple different ways you can do that. One is with what's called a deburring tool, and this is a little V-shaped tool. It's a carbide cutter, and what we do is we take that and we basically just run it on the edge, and that smooths out any burrs, any cut marks or debris.
Manufacturing slag off there.
Right.
And
It
it
just cleans that up.
Exactly.
It's a nice-
The reason you want to do that is if there are burrs on either of these parts, when you go to join them, if you get a burr in between those two parts, you're not going to get a proper rivet tension. And then that burr will ultimately wear down to dust. When it's gone, now you've lost that tension that was in there, and the rivet is now loose.
Sure.
So you need to make sure you get rid of those burrs.
So we deburr the edges. Another tool that we use is a deburring tool, and that helps us to deburr the holes that are previously there. So again, there's little burrs on the holes, and we take this little swivel deburring
That'd be
tool.
true whether they were laser cut or if they were drilled.
Exactly. Either way, there's going to be some.
Leave a slight burr there.
Couple of turns on each side will deburr the part.
Yep.
And you do that for the entire part. So we're going to do just one row of rivets. So I'm going to go through and quickly deburr that set. You can see it doesn't take much to it.
Just a couple of turns. You don't really want to do much more than a couple of turns.
Yeah.
You're not trying to chamfer the hole.
Exactly.
You're not trying to countersink the hole. You're just trying to just knock those burrs off. So literally a quick spin with the
Quick
deburring
spin.
tool is all you need to do.
Yeah, that's what I found. One of the biggest mistakes is people will keep on going, and then as you say, you start taking away too much material and you're actually weakening that area.
Right.
So we clear that off. So we've got that deburred. Now you can see that we have holes lined up here, okay? Now in a typical kit, the next part, they would actually have holes in the mating part.
Correct.
So it's really easy then, because all you have to do is deburr, line things up, and then start assembling, right? So sometimes though, that's not the case.
Right.
So what we do is that we can then, and I'm going to use this as kind of a little prop on this side, we can line up the holes, get things lined up, okay? Now we want to hold that together, and fingers aren't quite enough for that. So we have some special tools that we use for that. They're called Cleco clamps. So they're just basically a spring clamp.
You'll hear the word Cleco used quite often in metal airplane building. It actually refers to the company, the Cleveland Tool Company, that originally designed these spring-loaded temporary fasteners.
Yeah.
And they're made by all kinds of other companies now, but everybody still calls them Clecos to this day because everybody knows what that means.
Exactly. So we take this spring clamp, and as you get it lined up, we're going to hold that together on one side, and then I'm going to take my other clamp and put it on the other side. And this helps us to hold things together that have not been previously drilled like that, okay? So that's step number one, okay? Step number two is we're going to use a battery drill, because into that,
Watch your finger.
And this is called matched hole drilling, where we're using a series of holes that are already there as a template or guide to drill the next step. So we drill through. Okay, now we've got the hole, we have to keep that hole lined up, and we do that with something called...
The Cleco.
A Cleco.
Not the Cleco clamp, but this is the actual Cleco tool itself. And if you look at how that works, just real simply here, it's a spring-loaded device that when you squeeze the plier, it extends out and the jaws kind of squeeze together. So when I put it in the hole and I release that, those jaws are going to widen out and they're going to clamp that metal together. So it's just a temporary fastener. It's really easy to assemble and really easy to remove when we need to. Just plug it in the hole, release it, and now that's holding those two pieces together there through that hole that we already drilled.
It's so easy.
It's very simple.
Yeah. So one of the things about Clecos is for every hole there's a different size Cleco.
Right.
So you can see here that this is a copper colored Cleco. We have some silver ones over there. This is for an 1/8 inch.
Yep.
The silver ones are for a 3/32, a smaller
A little bit
rivet.
smaller, yeah.
Right.
And they make larger ones too, and they'll be, some are black and there's various other colors to
Yep.
it. So you
Bronze.
look in your bin and you can see, okay, that's a gold one, that's an 1/8 inch.
Yeah,
You know that
so you
right
don't
away.
have to look at it and see for a marking that's worn off. I mean, how many times have you looked for a drill bit
Trying to read the
worn off marking of what size it is? You don't have to worry about that. If drill bits could be color coded,
It would be so simple.
so that takes care of that. And what the Clecos do then is keep things aligned so they're not sliding around. The clamps are good, but the Cleco pin are better because it gets everything lined
Yeah,
up.
once you get a hole drilled, there's no better way to keep it aligned than to have a Cleco in it.
Right, so we have one, and we want to get one more right away, so we're going to drill that, again with a battery drill. You can see it with a battery drill, it takes a bit of time to do that. If you tune in for our next sheet metal broadcast, you'll see us using some of the air tools for the solid riveting, and you can see a little bit of difference there. So we'll put that 1/8 inch Cleco in. We're doing 1/8 inch size rivets. Now we have two in, it's not going to go
Now
anywhere.
we can remove our clamps and get those out of our way.
Yeah.
And then we go ahead and drill the rest of those holes.
Now, if you've looked at the internet for different styles of aircraft buildings and builders' logs, you're going to see parts with hundreds of Clecos in them. And that's okay. It looks great to show off to your friends, but that's just a lot of work because ultimately you don't need to put a Cleco in every single hole.
It depends on the structure. Sometimes if there's a little bit of curve to it or
Yeah.
something, you might need to do a few more to keep the curve equal all the way around.
Yeah.
But on a flat sheet,
Flat sheet,
you don't really need to
Don't
fill
need-
every hole.
Exactly.
There's way more use of that pliers, and way more time
yeah.
consumed. than to
I mean,
really-
at first when you're using Clecos, it's cool.
Kind of fun, yeah. But believe me, you're going to do a lot of them, so there's no sense in getting it all done right away.
It gets tiring really quick, yeah, exactly. So we've got two in and this flat sheet, that's all we really need. Okay, so we're going to continue on and drill the rest of the holes.
Be careful not to drill your finger.
Yeah, we want to be careful about that. So we're drilling holes here. We have a few more to do. Those two Clecos are holding everything in place, so we don't have to worry about anything moving around. So there is something we have to do after we drill, and that goes back to deburring, right?
Because you're drilling, again, you're creating some more burrs. You took off the original burrs from the laser cut part, but now you created some more holes that are going to have burrs on them. So after you do your drilling, we'll quickly disassemble that part and we'll deburr those holes before we do our final assembly.
Exactly. Okay, so we've drilled through. Now, before we take it apart, this is a custom part now, okay, because it's custom made for this series of holes, all right?
Yeah, it's not necessarily interchangeable with other locations on the aircraft.
Exactly, so it's really important to make what we call witness marks on there. So I'm going to put an A here and an A here so that we know that this lines up that way. Otherwise, I mean, this is not that challenging. It's not a complex part, so we can probably figure it out pretty quickly. But
certain places in the aircraft, it might be very easy to get something in backwards or you know, upside down or something like that. But a lot of these parts do look alike from side to side unless you mark up and a down or left and a right or whatever.
And even something as simple as flipping it around this way is going to mess it up.
Mess it up, exactly.
So then we have our holes, and we're going to quickly deburr those again to make sure that we have all the burrs out. And again, you want to do both sides.
Yep.
Try to get that at an angle so everyone can see what we're doing here. With this thin sheet, it's good to help to support that a bit. So I'll let you do that one.
Yep. Sounds good. Quickly go down these and spin the tool quickly and get them all cleaned up.
Now here we come to an interesting spot where sometimes your part is going to be such that you really can't get the deburring tool in there completely square.
Yeah, so let's turn this around so everyone can see just a little bit this way. So you can't get in there really easy.
You can't really get in there because the tool is longer than the available space you have. And I've actually done this a couple of different ways. A lot of times I'll just literally unscrew the deburring head, which screws right out of the little handle.
Yeah.
And you can just take that by hand in here, and just a quick turn with your finger, just like that, is all you need, just to knock those burrs off.
Yep. The good news is there's not a lot of spaces that you have to do this, because it is a little challenging and a little tedious to do, but the flip side of that is that it's pretty easy to do. Yeah.
Yeah. You can also go in there, if you're real careful, you can go in there with a flat-sided, I've made deburring tools out of old hacksaw blades.
Oh, yeah.
And, you know, some like real thin metal like that, and you can sharpen an edge of those, and you just really gently slide those across there and knock those burrs off too. If it's a really tight spot where you just literally can't get your fingers in there.
Right, and then to the point of you can never have enough tools, there are some specialty tools that go onto your drill that you can deburr too, but we'll save that for another day.
Sure. So now we've got our parts deburred, both sides on both parts.
Yeah.
Now we look at our witness marks.
Make sure they're going together.
We line them up the same way we did before, so we know that our assembly is correct. And then we can again put our clecos in there, and then that will hold our parts together so that we can prepare for our final assembly. So we'll put the cleco there, put another one a couple of holes away so that it keeps up aligned. Now you'll see that those two holes are held aligned, which means that all the holes are now aligned.
Yep. And we're ready to go, kind of.
Yes, kind of.
Because this is kind of one step in the assembly process, okay? We're putting parts back together, but then depending on what you're adding onto this, you might take this sub-assembly apart, put it back together again before you do the final assembly.
Right, there might be, for instance, if this had a flap or an aileron behind this, now we'd have to get our hinge in there, and drill that and get that to match.
Kind of like this, where we have our hinge.
Like you show here, that hinge that's holding these two parts together would actually sandwich in between these two parts
Exactly.
here. So you need to fit that in there as another sub-assembly.
Yeah.
So that means you might have to reassemble and deassemble again, and maybe some more deburring. A little bit repetitive, but that way you know that whatever goes together in this stack up is going to fit.
And that's where they've said that you've built your airplane more than once.
That's right. You get lots of practice at some of these routine tasks.
And then finally, too, and again, this is a deep dive conversation, but then you want to talk about corrosion prevention before you do the final assembly, too.
Correct.
And depending on the aircraft, if it's built of 6061, some people won't do a lot, some people will.
Right.
And there's many different...
another thing to think about is you're building this aircraft for you.
Yeah.
But ultimately, way down the road, it might be somebody else's aircraft. So we live up here in central Wisconsin. We don't really have to worry much about corrosion up here. We don't have salt air. We don't have high industrial pollutants in the air. So we really don't have a lot of corrosion problems here. But if I was building this aircraft in South Florida, I'd be thinking a lot about corrosion.
You'd be worrying about it, yeah.
Because you've got high salt content in the air, and salt and aluminum just don't like each other at all.
Yeah.
So, but the person that buys your aircraft might be moving to South Florida. So
exactly.
it can be a sales point later on. Even if you don't think you need the corrosion protection, it's not that big of a deal to put it in there, and it doesn't add a lot of weight, but it might add a lot on the resale of the aircraft further down the line.
Exactly. And there's different ways to do do that. And we'll talk toward the end about different resources that you can get into to learn more about that. Again, that's another deep dive that we could spend a day on just by itself.
There's lots of different options when you start talking about corrosion protection.
So now we're ready for the final assembly, the fun part, okay? So 2 ways to go about it. One is with our manual rivet gun, which is underneath here, okay? So we have this set, and we've got some pull rivets. So the pull rivet looks like this. It is the rivet with a head on it.
The rivet body there,
And the body is sized in various diameters. This happens to be an 1/8" rivet. And then there's a mandrel, and the mandrel inserts into the rivet gun. The mandrel is pulled by the gun, and that essentially collapses the rivet and squeezes on essentially holding the parts together.
Yeah. If you look really close to this, it's hard to tell in the camera, but there's actually a kind of a ball on the end of that mandrel. And when you pull it, it tries to pull that ball up through the rivet, and that expands the rivet out and does your gripping.
Yep, exactly.
And then once you reach a certain tension, the mandrel breaks off.
Snaps off,
It
yeah.
stays in there, and the part that was sticking out of the rivet is gone, and the rivet's all ready to go.
Yeah, so lots of different ways to do that in terms of how to put the rivet in, but I like to put it in the gun because I have control over it then, and then we put it in the hole, and then we...
Make sure that you're square with the part. That's an important part of any riveting operation, is make sure that you're not tipped, angled. You want to make sure that your rivet is perpendicular to your surface.
Yeah, you want to really look at that, because if you look at it in certain ways, it might look good to you because you're tilted that way when it actually isn't. So that looks pretty good, huh?
And you can actually feel it. If you kind of feel the rivet gun, you can almost feel when that head makes good solid.
So I'm going to start pulling on this, and it might take more than one pull, and it snaps off.
Yep, and there's your
the
rivet.
mandrel pops off.
Mandrel goes in the garbage or in the recycle bin,
and we've got a rivet.
There's your rivet in place, all ready to go.
Now, a lot of work.
A lot of work. Lots of good muscle.
Yeah.
Really hand exercise, this is the way to do it.
You don't have to go to the fitness club when you do that.
That's exactly right.
So the better way,
the better way, people that really don't want all that exercise, is to use our power riveter, our pneumatic driven riveter. And again, just like Mark showed you, I like to put the rivet in the gun first, so that I've got good control of that rivet. And then see, that's what it fell out anyway. So we'll put it in there again. Now I get in my hole. I make really sure that rivet is nice and square. I can kind of feel that. Hold the gun.
Boom, done.
There's your mandrel's gone, and your rivet is set.
Yeah.
Simple as that. And those, you can do those many in a short period of time using the power rivet.
Well, you saw the difference there. I had to pull this a couple times. That was just one squeeze. Now, depending on the rivet style, there are many different types of materials. There are stainless steel rivets, there are aluminum rivets, there are alloys. It might take a little longer, but it goes very quickly, and it's not that hard to do.
It's real simple. Very simple.
So let's finish that off real quick. You do this side, and I'll do that side. We have about maybe 5 minutes left, so we want to wrap through things and very easy
once
to
you get
do.
a couple of rivets in there, then you can take your clecos out and then rivet the holes that the clecos were in. Right. So Mark, I'll turn the gun over to you and I'll
Get the clecos out of the way. Perfect.
See, once those clecos are out of there, you've got your nice hole, just go ahead and put your rivet right in.
Great. 2 more to go. You can see it. So we've made a part in literally the span of a few minutes, and it's ready to fly, basically.
Yeah, that part's ready to go, at least this particular assembly procedure. There you go.
Great.
There's your part right there. Really simple.
So this is an example of, again, pretty much a standard kit, because a standard kit might not have all the holes cut or pre-punched.
Some of them they have to wait because of the different layers of assembly.
Exactly.
They can't, a simple part that they know it's just going to be these 2 parts together, a lot of times both parts will have the holes in them.
Yep.
But with the stack-up assembly or something where you've got to kind of custom align something, often you'll have one set of holes there, just like we had in this part, and you'll have to drill the rest.
Yep, exactly. And you can see the pull riveting design, so much quicker and easier. And unlike a driven rivet, so with a driven rivet, and again, we'll demonstrate this in our next sheet metal presentation, but you're using a rivet gun and a bucking bar underneath there. Now, you've got a lot of things moving around here, okay?
That pretty much going to be a 2-man job.
It really has to, especially on some of the bigger assemblies, as compared to just holding this
And pulling it.
and pulling a rivet. Much faster, much easier.
Right.
I think the only downside that I see with this is that just you have to get used to the weight of the gun. There are other more streamlined ones, but the benefit is it's so much faster and
And
easier.
a lot of times, if you're working on a part, you can stand it vertically, and then the weight of the gun is just down. You're not twisting it like this. You
Yeah,
just bang, bang, bang,
bang, bang, and you're done, yeah. So then we go on to the final assemblies, and then we finish our corrosion proofing, painting, again, another deep dive conversation, but that would be the next step. And then getting it through the certification process, where the aircraft is finally all put together. An FAA designated inspector will come out and look at the aircraft, do the airworthiness inspection. Hopefully though, what you've done is you've connected with an EAA technical counselor, a mentor that will kind of look over your shoulder during the building
all the way
process.
through the process, from
Right.
beginning to end. Yep.
Right.
And that person will kind of do a pre-inspection inspection to make sure there wasn't anything missed or something might be done a little bit better. So when the FAA gets there, it's a breeze. You just roll right through it. There's no problems at all.
And that's another great resource that EA offers in terms of home-built aircraft is technical counselors. When you're getting to the point of flying it, flight advisors as well. And the flight advisor program is going to counsel you, help you develop a safe and effective flight test program so that once you get to the point of getting your aircraft ready to fly, you're going to do that in the safest manner possible so you can get through the flight test phase and then ultimately fly your airplane.
Exactly.
It's that easy.
That pretty much explains it. I mean, in airplanes, you think it's a big project, but it's just
It's a lot of little,
a number of small projects
a
that
lot of
add
little
up to a
steps,
big
yeah.
project.
And then ultimately, as you're going along this path, there's a lot of great resources. So we talked about a couple of them already, the EA technical counselors that will oversee or look over your shoulder essentially as you're building your airplane, flight advisors when you have it ready to fly, but also in between, tuck in there, is resources on our EA website, the hints for home builders.
Videos,
And you've seen us do many of those, and if you go to the EA website and look up the video section, you'll be able to see the EA Hints for Home Builders videos. We have an extensive collection of DVDs and books on home-built aircraft projects as well.
and don't forget your local chapter. I mean, you've got many people that have great expertise. You got maybe a couple of multiple airplane builders, maybe some A&P mechanics, a number of people that have been down this road already, and of course they're in the chapter, so you know that they're more than happy to lend a hand and help you find your way through the project.
And that's the great part too. It's an in-person kind of camaraderie that is going to help you. I mean,
It truly is, EA truly is a family affair. It's, everybody's pulling together to make sure that everybody enjoys it and has a safe product at the end.
and it's so much fun that way because you're sharing what you're doing, and folks are sharing their experience and their excitement about what you're doing as well. And at the end of the day, you jump into this amazing thing that you've built and take off and have a great time.
Exactly. Yep.
It's so much fun.
That's exactly right.
Well, that's all we have for right now. We're going to be back a little bit later on today talking about wood construction. And then throughout the week, we'll be talking about another session on sheet metal. We're going to be doing some composite construction, some fabric covering. We're going to talk about welding as well, TIG welding, gas welding too, and some of the other aspects of building home-built aircraft. Well, my name is Mark Forss, and again,
I'm Joe Norris.
we really appreciate you tuning in for the first inaugural session of our EA Together in Sport Aviation, Spirit of Aviation Week. There it is. Thank you very much.
Enjoy it, and we'll see you back next time.
Okay, see you later this afternoon, everybody.
I'm Tim Buttles, and this aircraft behind me is a very low-budget aircraft that